Hello and welcome team. Here's the video for our reference and guidelines. Kilometer Cuba Audible Alarms.
Dave, thanks for joining us today. I know Hoshizaki uses audible alarms to indicate the status of their units. Can you give us a little rundown on what it looks like with the performance and the indication of what those alarms mean?
On the KM models, we have 5 alarms. 1 through 3 are resettable through the alarm reset button, and 6 and 7 are going to be reset by the board once the voltage is corrected. So the 1 beep alarm is that the evaporator reached 127 degrees during harvest. What we're trying to find out is why the evaporator got so hot. The first thing we're going to check is the thermistor, because if we hit the alarm reset button and the alarm doesn't clear, that means the thermistor is shorted. The next step to check on the machine is hot water migration. Now, hot water migration is the most difficult thing to diagnose on our unit because you're not going to be monitoring the temperature of the water for the next couple days. So what we like to do to diagnose that problem is on the back side of the machine where the water line meets the unit, there's always a brass fitting there. And what we're going to do is we're going to put a little dab of Vaseline on that brass fitting. We're going to continue to check the machine. If we have to come back, we come back when the alarm is going off and we verify that the Vaseline is still there. If the Vaseline is melted on the floor, then that means that you have warmer than 85-degree water coming into the unit. After we confirm that hot water migration is not the problem, we're going to go and check the hot gas valve. Now, we need to check the hot gas valve for an electrical problem or a mechanical problem. Once we come out of harvest, we're going to confirm that the hot gas valve doesn't have any power. Once we can confirm that, then we're going to wait until we go into the free cycle to confirm that the hot gas valve is not leaking by. Now, we're checking the hot gas valve in the free cycle because at that point, the hot gas valve is closed. We should have no flow of refrigerant at that point. What we're going to do is we're going to take a temperature across the hot gas valve. We should have a 10-degree differential. If the valve is leaking by, we'll have less than a 10-degree differential. And I want you guys to understand that if a solenoid valve was energized, you should see the same temperature on both sides because you have refrigerant flowing from one side to the other. After we check the hot gas valve, we're going to move over to the headmaster. Now, the headmaster is only for remote machines. And before we start diagnosing on the headmaster, we need to confirm that the charge is accurate because a low charge will make that headmaster bypass. Now, the problem that you're going to see on this machine that causes this 1 beep alarm is that the headmaster is bypassing when it doesn't need to, and we're sending all that discharge gas straight into the evaporator. And that's superheating the evaporator, creating this 1 beep. A 2 beep is a long harvest 2 times in a row. We're looking for anything that would make that extend that harvest time. Now, on our boards, to be able to be considered as a long harvest, the machine has to run in harvest for 20 minutes. It has to do that 2 times in a row to create this problem. The first thing we're going to check on the 2 beep alarm is the thermistor. In harvest, the board is looking for that thermistor that's mounted on the suction line to reach 48 degrees. That's how the board knows that there's no more ice on the evaporator. To be able to check this thermistor, what we're going to do is we're going to put the machine to run. We're going to let it go into the free cycle, and once that suction line reaches 32 degrees, we're going to disconnect the thermistor off the control board and ohm it out. It should ohm out to 6,000 ohms. If it doesn't ohm out to 6,000 ohms, we're replacing the thermistor. Once we confirm that the thermistor has 6,000 ohms, then we can move on to the next step, which is confirming that the hot gas valve is energized and refrigerant is flowing through it. We need to confirm that we have 115 volts at the valve, and then we're going to take temperatures on the inlet and outlet of the valve to confirm that we have refrigerant flowing through it. If we have a bigger split, there is a possibility that the valve is not working properly, and it might need to be replaced. Once we confirm that the hot gas valve is not leaking by, then we can move on to the next step. Next step, we need to confirm that the liquid line valve is not leaking by and the TXV is not leaking by during harvest. We're going to confirm that the liquid line valve is not leaking by taking a temperature across it. We should have a 10-degree differential. And we're going to take a temperature on the outlet of the TXV to see if it's feeding anything into the evaporator. There is a possibility that one of these things is the problem. If it is leaking by, we are replacing the part. Once we confirm that the TXV and the liquid line valve are not leaking by, we're going to move on to a low charge scenario. Now, to be able to confirm the low charge scenario, we need to reference the service manual. In the service manual, there's a chart You're going to line up your air temperature and your water temperature, and those are going to be your pressures for your machine. We're going to check pressures 5 minutes into the free cycle. You're going to check your suction pressure and your head pressure. If the charge is inaccurate, we're going to recover and weigh in the charge. Once we confirm that the charge is accurate on the machine, then we can move over to the compressor. We're going to confirm that the compressor is not inefficient. What that means is the valves are broken in the compressor and we're not moving refrigerant through the system. For that to happen, the valves need a break. You're going to have equalized pressures on both sides. And to confirm that the valves are broken, you're also going to take an amp draw on the compressor. With the valves being broken, the amp draw on the compressor are going to be very low. Once you have two of those items, equalized pressures and low amps, we'll be able to confirm that the compressor is inefficient, and we'll be replacing the compressor at that point. Once we confirm that the compressor is working properly, then we can move on to the water regulating valve. Now, the water regulating valve, this only applies to water-cooled machines. If the water regulating valve is leaking by during harvest, it'll cool that refrigerant down and we won't get the right pressure at the evaporator, making our harvest a little bit longer. If our water valve is leaking by, we are replacing it. Once we've gone through all the steps, if the alarm comes back, we're going to check that Vaseline that's on the water line on the back side of the unit to confirm if we have hot water migration coming into the machine. Let's talk about the 3-beep alarm on the KM model. The 3-beep alarm means that the machine was running a long free cycle 2 times in a row. To be considered a long free cycle, the machine has to run about 50 minutes into the free cycle to be considered a long free cycle. Does that 2 times in a row, automatically goes off on a 3-beep alarm. We're looking for anything that could cause a long free cycle. The first stop is while we're running the machine, we're going to confirm that the water pump runs. If the water pump is not running, we need to confirm that the board is calling for the pump and that we have 115 volts to the water pump. The next step is to check the float switch. We need to confirm that the float switch is showing open and closed. During the freeze cycle, the float switch is in the closed position because the water tank is full. As the water gets consumed, the float switch shows open, and that's what puts the machine into harvest. If the float switch is stuck in the closed position because it's dirty or because the switch is bad, that means that the machine is going to run a long free cycle and time out on that 50 minutes on the board. Now that we confirm that the float switch is working, we're going to move over to the water valve. We need to confirm that the water valve is not leaking by. The way that we're going to do this is we're going to shut the machine off. We're going to remove the hose that runs from the water valve to the evaporator. Once you disconnect that, you're going to confirm that there's nothing steadily coming out of the water valve. If the water valve is leaking, we'll be replacing it. Once we confirm that the water valve is not leaking by, we can move over to the TXV. Now we need to confirm that it's metering the right refrigerant into the evaporator. With machines that are a little bit bigger, that they have multiple TXVs, it's a little bit easier. We're going to do a temperature check on the outlet of the TXVs going to the evaporator. They should be within 2 degrees of each other. If one TXV is higher than the other, we'll be replacing the whole set. Once we confirm that the TXV is working properly, we can move over to a low charge scenario. We're going to check the pressures 5 minutes into the free cycle. And with those pressures that we see on the machine, we're going to reference them over to the service manual. In the service manual, there's going to be a reference chart for our pressures. We're going to need our ambient temperature and our water temperature to be able to find the right pressures for that machine. Once we confirm that the charge is correct and accurate, then we can move on to the hot gas valve leaking by. If the hot gas valve is leaking by during the free cycle, the machine is going to send hot gas into the evaporator while we're making ice. And they're both going to cancel each other out. So the freeze time is going to be a lot longer. To confirm that the hot gas valve is not leaking by, what we're going to do is 5 minutes into the free cycle, and the 5 minutes is really important because in 5 minutes prior to that, the hot gas valve was energized. We want 5 minutes to cool down on that valve, and then we're going to take a temperature on the inlet and outlet of that valve to confirm that we have a 10-degree differential. That valve is closed at this point. That's what we're looking for. If we have a smaller differential, the valve is leaking by. The science behind that is if you were checking a solenoid valve while the valve was energized and you had refrigerant flowing through the valve, you should see the same temperature on both sides because the refrigerant is flowing. Once we confirm that the hot gas valve is not leaking by, then we can move over to the liquid line valve. Now, the only way that the liquid line valve would fail on a 3 beep is if it wasn't opening or wasn't opening enough. What we're going to do is we're going to confirm that we have power when we're in the free cycle, and we're going to take a temperature across that valve. And what we should see is the same temperature on both sides. If we don't and we have a differential, we'll be replacing the liquid line valve because that means that it's partially restricted. Once we confirm that the liquid line valve is working properly, now we can move over to the compressor. Now what we're looking for on the compressor is for inefficiency, broken valves. If we have inefficient compressor, we'll be seeing equalized pressures on both sides and very low amps, somewhere between 3 and 4 amps. If the compressor is inefficient, we'll be replacing that compressor with the dryer. Now that we found that the compressor is working properly, let's move over to the headmaster. The headmaster's job is to maintain head pressure. When the outside temperature drops drastically, the job of the headmaster is to maintain that head pressure. To be able to diagnose the headmaster, we're going to take a temperature on the inlet and on the bypass line. The bypass line should be ambient temperature. If the headmaster is bypassing, we'll be replacing the headmaster. The next alarm that we're going to look at is the 6 and 7 beep alarm. The 6 beep alarm is a low voltage alarm. The 7 beep is a high voltage alarm. To be able to see what is powering up the board, we're going to go straight to the K2 connector. K2 connector has 2 red wires on the board, and that's how the board gets power. The board needs 10.5 volts to turn on and the lights to turn on. Now, on the 6 beep alarm, the 6 beep alarm is a low voltage alarm. So if the voltage is coming in lower than 115, like 90 volts going into the transformer is not capable of putting out 10.5. At that point, it's going to put out like 9 volts. Now, 9 volts doesn't energize the board. 10.5 volts energizes the board. So if we're having a high voltage alarm, that means that the voltage going into the transformer is higher than 115. If the voltage is coming in at 137, the transformer is not capable of putting out 10.5 volts. It's going to put out something a little bit higher, like 13.4. Alarm 6 and 7 are not capable of being reset by the alarm reset button. Once the voltage is corrected on the board automatically resets.